Okay, cool. So in terms of formalization of F strings, formatted strings, some kind of times, when expression components inside F strings can now be any valid Python expression, including reusing strings of the same code as containing within that particular type of F string. What I mean is kind of this. This particular formalization of F string introduces a scenario where you can use more or less the same code within that particular type of line in itself. You can also be able to use formatted strings within multiple lines. Previously, that was not possible in versions 3.11. And all kind of that. This is what I mean. If I want to just kind of like print my name, I can be able to use double quotes, F double quotes. Previously, it was not possible to use double quotes within hello and within that part. The standard was that if you've already used that, then you can use a single quote. You get to see that. But now, this is possible. And the reason why that is possible is that we can have nested functions within a particular kind of code as compared to how it could be in the previous ways. The others, that one I could have shown you via live code here, was to be able to kind of like write multiple lines. I know as a programmer, probably you've written a lot of multiple lines. With versions 3.10 and 3.11, it was not kind of like possible. It was only allowing you writing within a single line. You get to see that. But now an improvement is this, more or less the explanation that the Python team was having when releasing this particular type of version is kind of like, how does a user, what's the user, because these are already implemented in programming languages like Go, we have JavaScript and all kind of that. You can be able to like implement multiple lines. You get to see that when you're using this particular kind of strings, but why not in Python? So based on that user kind of experience, when they are comparing one language to the other, how does it feel having to use that? So that was the need. And then the second item that I really want to talk about it is improved error messages. One thing as a developer is that you want to get to some kind of like see some, based on the error that you're getting at in your terminal, then you can be able to get to see where the problem is, especially perhaps when it's a syntax error, maybe it's another kind of error. So this particular type of version 3.12 focused on errors in having to bring them closer to the user to be able to get to see maybe if you missed one or two things. The first is the error, and then we have syntax error, and then the import error. So how does it occur? Thank God I wrote this on VS Code, and then placed it here so that we can just kind of like check the pictures. Now, somebody will be able to kind of like write import AYZ from BYZ. What normally is the standard if you want to import something? It tells you right there that the syntax error is, did you mean use from? So essentially it helps you. Previously this was not. So previously this was not possible in other versions of 3.10. So when as a developer such a kind of a thing happens, and you get to know that you need to really change this. So it is improving on the error messages. Got that clear? Does that make sense? Yeah. And then the next one is name error. Maybe you want to declare a particular type of variable, let's say kind of like say, and you've not maybe defined it. Or some kind of times maybe you've written a class, and then like this one, you've defined a class A, you've instantiated a method that takes in the parameter of self. You get to see that. And then there's an instance of that particular type of method to that function, which is self.pledge. You've given it maybe a value of 1. If you don't define that, then it gives you an error message that the pledge, that particular type of word there, is not defined. And then the module import error. Sometimes modules from the standard library are now potentially suggested as part of the error messages displayed by the interpreter when a name error is raised to the top level. So when you typically raise that name to a top level, and then these are part of the core modules that we have in Python. You get to see that. If you fail to be able to kind of like import them, like in this particular kind of example, maybe you kind of like used the sys module, but you hadn't imported it earlier. What is it intentionally tells you is that did you forget to be able to import this particular type of core module that is being used in Python? Previously, this is not possible. You'll not even get to know that, oh, I didn't import this, I didn't use that. I call it, but I hadn't done the import of this particular type of core module. So that is how Python 3.13 improves error messages. Couple of few minutes to go. And then it also allows async functions to be used as coroutines. One thing you get to know, especially in asynchronous programming, is of the fact that, you know, we have to use async await. You get to say that, especially we have either synchronous or asynchronous state of programming. So in Python 3.12, async functions can be used directly as coroutines, simplifying asynchronous programming. This is what I mean, so that perhaps it makes sense. In the previous version, that is, let me talk about maybe 3.11. You having that, it's maybe a sync function, so we have that, and then await on given that function or some async operation. You get to see that. With now, there is really no need of await, because what happens essentially is that Python 3.12 internally handles the asynchronous of the function call. So when you call an asynchronous function within another asynchronous function, you get to see that the interpreter automatically recognizes that the inner function is asynchronous and handles that particular type of version execution effectively. So this normally happens, especially even from the previous code that I showed you. We had like almost 2 async functions within that way. So you don't need to implement await and await again. It's more or less like going to have a lot of repetition. And just as I told you, we are kind of like with improvement in a programming each and every release, there's always like we want to minimize. We don't want to kind of like write a whole lot of block of code implementing the same thing if you can even do it on a single line. So what essentially happens with 3.12 is that, you know, it will be able to recognize that, you know what, that particular type of inner function is also synchronous. So there's no need for us to use another await function again. Does that make sense, guys? Looks like I talk pretty much. I may be talking simple fast. I talked about this in terms of performance improvement. So it's kind of like that. There's a giant leap in performance with Python 3.12 as compared to the previous versions. It's always up to 60% improvement in terms of performance, especially when you're checking about how they've be able to like update, do a lot of things in terms of modules, in terms of like the entire logic and the syntax, all kind of that. This is always geared because Python has always been lacking, especially when it comes to performance as compared to some languages like Golang. So in terms of performance, we talk about this, that there's been a giant leap. There's definitely an in-depth way of explanation on how they've done that, but probably we may not have the gift of time to be able to explain all that. Another one is to be able to, the last one here I wanted to talk about is, you know, the generic types. Now, before Python 3.12, if you wanted to create a generic class, so a generic class is essentially a class that works with multiple types. You get to see that it can be able to work with multiple types. I mean, is it a string, is it an integer, is it a boolean? You get to see that. So that's what we mean by generic type defined within that particular function. You had to use type var or generic from the typing module. This approach requires you to be able to use type var function, which acts as a placeholder for type and then specifies that the class in itself is generic, so that Python gets to understand that, you know what, this class is generic. And that's exactly what we had there. So from typing, you have to import generic, you have to use type var, and at the same time, you have to write everything there. You have to like use type var, generic, write everything there. We have covariant is equal to true, bound is equal to true. You define that particular type of class. It's a whole load of block. But look at how Python 3.12 has simplified almost like 6 lines of code into 2 lines of code, such that thing is that you'll be able to kind of like write a class and be able to, within that kind of list of string that you've instantiated, you give it that typing module, and that in itself tells it that it's a generic type. So Python already identifies that as a generic type. So we are doing away all load with all this kind of like having to write type var, covariant, all that kind of code into just writing here and calling in, having to mention that, you know, this particular type of whatever we're talking about here is a string. You get to see that. So you don't have to write all that is happening. And so that's how Python over time has been able to like improve and work on a whole lot of things. And then it can also work on generic functions. When we talk about those generic types, so we are also talking about generic functions. If you wanted to write maybe a particular type of type var, and then you have to also write that type var as well, and then you define that particular type of function. It takes A, takes that value, all that kind of block of code. The new syntax deals away essentially with having to import that entire module, use type var function into only defining function. And after you've called, mentioned that, you know, this particular, you've given the value t, that's the most important. It already identifies, Python already identifies that that's a generic type. So essentially, this t here is enough to cover all for all this and all that. Does that make sense? It makes it look easier, right? Yeah, and that's how things gonna be. I want to talk about the last one is compression inlining. So when you write compression and in Python is either list, set, dictionary, or generator. In other languages like, you know, Java, we don't have dictionary. We essentially have hash maps. You get to see that. So Python internally creates temporary objects and scopes to be able to handle your iterations and expressions. And this particular type of compression inlining comes in to be able to like reduce the amount of overhead within the process of you know, making that kind of compression, so that it essentially reduces the entire loop. This how, and I said a lot of hard words there, but this maybe within kind of that. So this particular type of function here is just kind of like, just to explain this code, is a roll dice method that takes in stuff, and then we kind of like initialize an empty list that, you know, and the variable give it to self.roll, and then we'll be able to like iterate for underscore in range. What does that mean? Underscore is just kind of like a placeholder variable. Essentially, we don't, majority of times as a programmer, you have to say for I in range. You get to say that because you want to use that I. Maybe it's an index or a value, but probably majority of times it's an index. But now when you're using this in Python, essentially it's just a placeholder variable. You don't want to use it essentially. The only thing that is that you want to iterate into that particular type of, you know, maybe a list quite a number of times, but you don't want to use that value. So that's the what about that? So, and then you'll be able to, that's what the code does, and then you'll be able to append that to the self.roll list that we had. So essentially, all this particular type of what's happening there, this how, if you wanted to kind of like iterate maybe quite a number of times within maybe a roll dice or something like that, that is how long it, that is the number of codes that it will be able to take for you to, you know, be able to implement that particular type of function. But with Python 3.12, you can essentially do it. What you're kind of like doing is that you essentially can do this within one single line. You get to see that. And that is what essentially is happening there. So I'm being told that probably my time comes to an end, and I think that was it from me. I had one or two like demos with my laptop, but that was not possible because we ran into challenges, and that is it. All right. Yeah. So just a minute before allowing for questions. So there's quite more. When you also check in Python 3.13, there's been quite of like improvement, but that improvement has essentially come up with improvement in terms of like also performance and enhancing error messages. So it's part of what you can be able to check in within the documentation. Any questions from there? They've essentially been in existence, but then whatever you are having to see is like improvement. Yeah. Basically, that new things that have always been brought, but Python 3.12 has been more or less like upgrade in terms of what we had and how we can be able to improve it. And that's why when you are even seeing comprehension in learning, you can be able to perform that if you will be able to want to work on comprehension, maybe it's a list, dictionaries, and all kind of that. But now we have a reduced number of code lines into essentially 4. We bring that to a single line of code. So that existed. But closely, there's some new ideas that were brought, especially in 3.13, but that was kind of like so deep, and I didn't see so much of a relevance to be able to talk about it here because it was so deep. So there's some kind of like new ideas that have come in Python 3.13, but I hadn't covered it still here. Yeah, but they're new. But this is just more or less an upgrade because we're focusing on performance and user experience. Another question? Yeah, so I hadn't introduced myself so much. I'm from Kenya, by the way. So I'm a Kenyan, and it was nice coming to Uganda, having to meet very cool people, and I must say, like, the experience is great. So I hope, like, we'll be able to kind of, like, use this opportunity to be able to learn new things, new ideas in Python, and that helps you, especially in your debugging process, because essentially that eases your process and enhances your productivity as well. From me, thank you.